Which of the following is the strongest acid? So when we talk about acid strength, we're talking about the extent to which your acid dissociates to give you a proton and the conjugate base. And so in general chemistry, to express an acid equilibrium, you had the acid equilibrium constant, or the Ka. And so the Ka is the ratio of the products, the concentration of the products over the concentration of the reactants at equilibrium. And so the more of these products that you have, the more dissociated your acid is. So we would say that's a stronger acid. So if you are given a Ka value, an acid equilibrium constant, we would say that the stronger the acid, the larger this number would be, because the larger number you have on the top of your fraction, the larger overall that equilibrium constant will be. So the stronger the acid, the larger the Ka value. And so in the case of these examples, we're not using Ka values, we're using pKa values. And this is how we typically express our acid strength as organic chemists, because it gives us a more convenient number to work with. So the pKa is the negative log of the Ka value. So we end up with a different relationship. So once you take the pKa, what we will find is that the lower the pKa, the stronger the acid. And so in this case, if we're given pKa values, as long as we know this relationship, we should be able to easily pick out the lowest number. And so if we compare, we will find this first option A is the smallest pKa value that we have, right, compared to the others. And so that is the strongest acid. Okay, and so now we've looked at it from one angle, the strongest acid. We're going to do another quick example. So I'm going to switch this out. And we are now going to use the pKa value to pick out the weakest acid. So if the strongest acid has the smallest pKa value, then the weakest acid we would expect to have the largest pKa. And so if we look at the options that we are given here, the largest pKa here would be for methanol.